Alright, so we are going to go through what VEX lesson 14 calls kind of the seaweed example. So in the last lesson we went over how to create a line that goes from a point in our geometry to a new point that we created, somewhere along the normal vector. So then the idea is, well, what if we do this multiple times and each one is a little bit different than the next? Then we might get something that ends up looking like this, right? Where if we kind of examine what's going on, I'll turn on points here so you can kind of see. I'll zoom in on one. So we started out with this point, and then we found a new direction to go in. We went in that direction a certain amount, and then we made a point, and we picked a new direction that's still related to kind of this normal down here. Then we picked a point. Then we created a new direction, made another point, and another, and another, and another, and so on. And eventually made a line out of those multiple points that we added, and they're still being animated because we're using time. So let's walk through this step by step. So this is one where some of these variable names are like horrible, like they're way too long, and I would never make my variable names like this if I was doing an actual project, but I'm gonna name them these things to make them more descriptive of what they're actually doing, so that it will maybe make the whole thing make more sense. So the first thing I want to say is I'm just declaring my variables up top to kind of clean up my code. So don't worry about this. I'm just declaring some variables that I'm needing. A couple of vectors, a couple of integers, and then a float. So let's go through this line by line and figure out what's going on here. So the first thing we're doing is we're creating something called a new line, and we're using our addPrim function that we learned about. But notice that there's no connecting points here. I didn't say like at PTM and connecting point or something like that. Right? I didn't do that with my line this time. Now, like several functions in VEX, the number of arguments that you give it kind of changes what the function actually does. So if all I give it is the first argument of 0, which is the geometry handle, and the second argument of polyline, which is a string, all it's going to do is it's going to go ahead and just create an empty line for me, and the line's just kind of going to kind of basically just be sitting there. Like if I comment out the rest of this code, you will see that my code runs just fine. There's just kind of this invisible line that doesn't really have any points or anything, just kind of chilling in space, right? But the thing is, we can add vertices to this line using the AddVertex function. And what the AddVertex function does, it says, okay, what geometry stream do you want me to look at? Which line do you want me to look at? And then which point do you want me to add to the line? So we're going to kind of use that basically to our advantage. So we're going to start with new line equals addPrim, geometry stream 0, and what type of primitive? A polyline, just so we have kind of a placeholder. And the next thing we're going to do is use the step size, just so we have like something that we can control with a channel. So now we get into kind of the tricky part. So of course we're going to use a for loop because we want to do this multiple times. We want to we want to basically create multiple points above these the points of our geometry. So we'll start with a for loop. So we have our all-important counting integer. We'll start at 0. We'll do it 16 times, and then we'll add 1 each time to I. So every time you go through the loop, I is increasing by 1. So the first thing we're doing is we're creating kind of an offset, which was kind of like the noise vector that we created in the previous example. And this time we're using curl noise, just a different noise function. You can research it um, and kind of dive more into it if you want to. Um, but here's the VEX function here. So it says computes divergence-free noise based on Perlin noise. So I'm not sure what divergence-free means, but I do know that this noise does seem to give more even kind of results, even the normals that are pointing in the negative direction and the normals that are pointing in the positive direction seem to kind of have like a uniform behavior with this noise. Like if we were to change this to regular noise, I think you would see we have kind of that problem where let's see here if we can kind of see it. Let's see if we do the step size something bigger, like 0.25. Doesn't seem to be hurting it too badly. But obviously it's not as interesting as if we use the curl noise. So you know, different noise functions are going to kind of give you different behaviors, so don't be afraid to kind of experiment around with them. So what do we want to use with the curl noise function? We want to go ahead and use each point's position, and we'll subtract time to kind of animate it, and then we'll add I. And what this does is this ensures that each time we run through the loop, this noise will be changing, right? Because our I number will be changing each time we go through the loop. And then I'm multiplying by 0.05 again, just as like kind of a dampening thing. You'll kind of see sometimes that different lines of code that you add to your effect, sometimes you want to dampen the amount that it's kind of affecting everything, so you can go ahead and multiply by like a smaller number. And then I'm multiplying by I again. The reason why I'm doing this is because I want these to be anchored. So if we zoom in here, if I don't do this, so if I comment this part out, then what's going to happen is if you look at the base here, see how the base is kind of jumping around? It's not anchored to the point that it started at. The reason is because right away the noise is kind of offsetting in some direction. So basically the very first time we go through it, it's already offsetting. We don't really want that. So if I multiply it by you know, this whole I times 0.1 thing here, then remember I is 0 the first time around. So the first point that it adds to the line, it's not going to offset it at all. It's going to basically multiply everything by 0. And oops, let's see if semicolon there. And you'll see what that does is that go ahead and snaps this into place. It kind of locks it down so that there's no offset the first time we go through the loop. And then the other kind of cool benefit to this is that each time you go through the loop, because this number is getting bigger and bigger, the overall effect is more pronounced towards the end of the line. So if you look here, like towards the base of the line, it's kind of wiggling a little bit, but then it starts to get crazier and crazier the more out here we go. And for example, if I do this, like, let's say we'll do like 45 times, and we'll make our step size like super small, like 0.001 or something like that. So that's like, that's going a little bit too crazy. Let's do, that's still a little bit, I didn't plan out exactly how, but basically if I kind of went with these I could play around these parameters to kind of get the look that I wanted, but I found that these numbers kind of worked for me, so I'll just keep going with the example for this one because I don't want to get bogged down in it. So So here we're creating the offset, and again it's changing every time we go through the loop. And then now we have a new vector called position to make the connecting point. So this is basically saying this is where you're going to make the connecting point. You're going to start at your position, right? And you're going to go in the direction of your normal. You're going to go further each time, right? Because the first time you're not going to move at all. You're going to be at 0. But then the next time, when I is 1, you're going to move in the normal direction, a distance of 1, and then 2, and then 3. But then we want to kind of control this with the step size, right? So the step size is linked to this channel here, which I called line length. So this kind of controls like how far you go out each time. So if we look at this here, you see that it's traveling in a certain amount each time, and we can control that with this step size here. But then the whole point of making the offset was so we could add it to the position and so we could animate it, right? So that's what this plus offset's doing here. So now every time it goes through the loop, we have a new position to make our connecting point, and it's going to be a little bit further away from our starting point every single time, and it's going to be a little bit more dramatic as far as its offset each time. So then we need to, so we've got basically, so this, I'd say these two lines are probably the trickiest, right? Those are probably the trickiest to understand. But once you have that, you kind of realize we have a position vector that we can use for our, to make our point in. So the only thing to do is to make a connecting point. So here I have my connecting point, which is an integer that I initialized up here. And we're going to go ahead and add point to the first geometry stream, and where are we going to add the point? Well, the position that we created for that explicit purpose. So that's why I have that vector here. And now that we have the connecting point, we can take advantage of the AddVertex function, which again takes geometry stream handle. It takes the primitive that you want to add the vertex to. So remember, we created an empty one up here. So if we keep using new line here, it will just kind of keep adding points to this line. It will build it kind of as we go. And then what point do you want to add to the line? Well, the connecting point that we made. So that's it. That's basically how you kind of create this. Now one thing I can do is I could do a smooth and we could smooth position and to try to get it like to be a little bit more like not as crazy. Now the problem there is we lose our anchor point. So let's see. Yeah, it's smoothing the entire geometry. So what I want to do is I want to go ahead and we'll do kind of an interesting thing here where we're going to split into two different streams. So we have, so I'll take my original sphere, and then what I'll do is, let's see, I should have, so I'll go ahead and do a add sop to get rid of the, that's gonna, how can we get rid of the polygons here? We could delete the geometry before we do this sort of thing. So there, that should work. Yeah, so now our anchor points are anchored, and we've got some smoother lines here. So, another example of how you can create lines and get some animation by using an offset created by noise. So, pretty cool example. You could probably think of like a lot of different applications for this. whether it's like seaweed or like, I don't know, some kind of weird organic like hair kind of system, but that should give you a pretty good idea of how to use addPrim, addPoint, and addVertex. Those are the three functions that we really want you to focus on. So even if you think this setup's a little complex for you, or maybe it's like, oh, I wouldn't really necessarily know how to do that, try to focus on just the addPrim, addPoint, and addVertex functions and see if you can at least kind of use those. So maybe if we kind of back it way up and just do something like more basic. So I'll create a grid. Or you know what we'll do? We'll do this. We'll create a line. So we'll make a new line, and we will. Sure, this is fine. So point wrangle. So what we could do is, let's see. So we could say, let's say we want to add a vertex or something like that. So we could say, oh, let's add a vertex. And we want to add it to geometry stream 0. We want to add it to primitive 0 because we know there's only one primitive here, right? See, I'm in the primitive tab and there's only one primitive. And we want to add new point. So let's go ahead and create a new point. So add point. Let's go integer new point. So we basically just have an integer to store this new point. Remember, the add point spits out an integer, the add point function. So we want to add a point. We want to add a point to geometry stream 0. And then where do we want to add it? Let's go ahead and add it to 0. We'll do 1 comma 0.5 comma 0, something like that. Let's see, of course I broke the, see, do I do primitives here? Let's see what it says here. Add vertex to maybe I don't have the prim number here. Yeah, so I think what I have to do is go int prim. Actually, let me think about this here. Let's see. So unexpected identifier. Oh, yeah, well that makes sense. There we go. So it's interesting what we did. So if we bypass this, see, here's our line here to here, and we added a new point to our line over here at this new position right here. Now it's kind of interesting, the numbering here. It says 0, 1, 3, and if we think back to our original discussion about parallelism, it makes sense because every single point in this geometry made this new point. So we just want 1. So we'll just have it run once on point 0. So there we go. So we added a point here. So, you know, like, yeah, okay, this example is kind of silly. It's like, why would anyone ever do this? But sometimes it's good to kind of do these really simple ones just so you really understand what these functions do. And then once you kind of are a bit more confident on these simple examples, then, you know, you look at something like this, and all of a sudden it's not so scary anymore, because anytime you run into that function like addVertex or addPoint, you're not like, oh, black magic, mysticism, you know, I don't know how this works. You know, you understand, oh, okay, well, the AddVertex function takes a geometry handle. It says, hey, what primitive do you want me to add a vertex to? And then, yeah, what point do you want me to go ahead and add to it, right? You kind of understand that. So now this line makes a lot more sense now. And so now when you're building up kind of the complexity of your systems, yeah, it's still kind of a lot. It's a lot to kind of take in, but you're building it out of like simple pieces, like relatively simple pieces. Um, I think maybe the confusing thing here is maybe like all this kind of math here, but try to think of it as uh, I is just changing every time we go through the loop. So when you're kind of reading this, just be like, okay, I is just changing each time, right? So the first time around, I is 0. The next time around, it's 1, and then it's 2, and then that might kind of help you make sense of it. And then from there, I think maybe the other kind of tricky thing is this offset, but keep in mind that it's based off of a noise function, and it's going to change each time because we're using the time parameter um, to kind of animate it. So I hope that was helpful and helped you out with that example. And yeah, that feels like a good place to stop this lesson. So enjoy. I hope this helped.